Hello everyone. In this session, we will take a classic approach to solve text classification problem. And here's how we will do it. First, we will use an embedding model, that is encoder-only model, to convert sentences into numerical representations or embeddings. These embeddings will then be fed into traditional machine learning classifiers like logistic regression, decision trees, etc. The main benefit of this approach is that we don't need to fine-tune embedding model. Instead, we only need to train traditional machine learning algorithms which we can run efficiently on any CPU. So, let's start coding! We will be using Google Colab platform to code. First, we will connect a GPU runtime. Now that we have connected to a GPU runtime, that is T4 GPU, let's first install libraries. The following libraries are needed. First is datasets. Then we have transformers, then we need sentence transformers. Let's install these libraries. The next step after loading the libraries is loading the dataset. We will be using the same dataset, that is Rotten Tomatoes. If you don't know about this dataset, please refer to the previous video wherein I have explained the entire overview of this dataset along with some exploration part. We will be using this data variable and we will be calling this load dataset function in this Rotten Tomatoes, and let's print the data. So, okay, from datasets, if you are running it for the first time, it will download the data and then it will print this particular data. Now we can see that this data has three splits: train split, validation split and test split. In train split we have text and label for each and every data point, and number of rows or number of data point in train split is 8530, and similar you can extrapolate for validation and text. Now let's print some data points from training dataset. So this 0 means the first data point. So the text is this, and here label 1, it means that this particular movie review is positive. Now if we print, let's suppose 7000 data point, the text is this, like it won't be long before you will spy and this is this. The label is 0, it means that this is a negative sentiment or a negative review towards any particular movie. Now if you want to print unique labels from the data, like so here we can take unique labels variable, and we will make a set. In this we will pass data of train of label, and we will then print this unique labels. Let's run this. So here we can see that it has 0 and 1. Now we have confirmed that this entire data has positive, that is 1, and negative, that is 0 movie review. Now let's directly go into using embeddings for text classification. Let's use embeddings for text classification. Now in order to load these embeddings or create embeddings for any input text, we will use a tool or Python library which is called as sentence transformers, which we installed in the very first step at the beginning. Now this is a popular package that makes it easy to use pre-trained models for turning sentences into numerical representations or embeddings. Now these will act as features for the next step. So let's import the sentence transformers function which we need. So from sentence transformers, import sentence transformer. Okay, then we will be loading one model. So model is equal to sentence transformer. For this session we will use this model, sentence transformers / all mpnet base v2. Now there is one benchmarking that is MTEB, Massive Text Embedding Benchmark. You can visit this website and you can see what all embeddings models are available, and you can select any of those models. So for this session I have selected this particular model. Now this model, this is a pre-trained embedding model, and this will be used to convert our text into embeddings or numerical representations. Now let's convert the training data first into embeddings. In order to do this, there is something called as encode function. So we will need this variable train embeddings. We will create this variable train embeddings, and we will call encode method, and here we will pass the text from the training data. So data of train of text, and just to show the progress we will set it as true. So this show progress equal to true shows the progress of the encoding process. We will also create the same type of embeddings for test split. So test embeddings equal to model.encode data of test of text, and also show progress will be equal to true. Let's run this block of code. So here it downloaded the model, and now see it is doing, so it is downloading the model 438 MBs, and it will start the embedding part soon. Now that we have generated train embeddings and test embeddings, let's explore this embeddings variable. So if we print this train embeddings, we can see that each and every text is now converted into numerical representation. Let's print the shape of these embeddings. So the output is this. So we have total 8530 data points or text, and each of the text or each sentence or each movie review is now represented as a vector of 768 dimension. So this particular NumPy array, or in short list of numbers, has shape of 768. So this is the gist about embeddings. Now we will do the fun part. We will perform classification. We will be using lazy predict package to run all the classification algorithm all at once instead of training each one separately with sklearn. It is a simple and efficient tool that makes predictive modeling faster and easier, helping you save time and effort. So in order to do this, we need this library installed. So pip install lazy predict. Now that we have installed this particular library, let's use this. First, let's import from lazy predict dot supervised. If you are solving regression based problems, there is a scope for regression analysis for lazy predict as well. But for now we are dealing with classification problem. Let's import other necessary packages like NumPy, and we also need random. Okay. Now we cannot directly use this train embeddings. We need to convert it into a NumPy array. So here train embeddings will be equal to np.array. In bracket input will be train embeddings. Similar with test embeddings. I'll just copy paste this variable np.array test embeddings. Now we need to extract the labels or target values from the training and test data split. So train labels, and we will have test labels. Here train label means np.array data of train of label, and np.array data of test of label. So these are training label and testing label. Now what we will do is we will just train on, let's suppose 50% or 10% of the training data. We will select random data points from training data set. So random size will be equal to int of, let's suppose we want to train for 20% of the data. So 20% into 0.2 into length of train embeddings, and we will have random indices which will be equal to random dot sample range of length of train embeddings, and then the sample size input, that is the 20% of the data. Then we will have sampled train embeddings. This we are doing just to save the time which is needed to train all the algorithms in classification. So train embeddings of random indices and also sampled train labels will be equal to train labels of random indices. Let's run this block of code, making sure that everything is ready. Now that our dataset is ready to train, let's initialize the lazy classifier. So CLF is equal to lazy classifier, verbose will be set to 0 and ignore warning will be equal to true. Then we will have models, comma, predictions equal to clf.fit. In this fit, we will need to input xtrain, xtest, ytrain and ytest. So here xtrain will be sampled train embeddings. Then we will have test embeddings. Then we will have sampled train labels, and here we will have test labels. Let's run this. Let's do the training part. Okay, we got an error, got an expected keyword ignore warning. Ignore warnings, it has to be a typographical error. Again, sample train labels is not defined. Oh, here typographical error, train. Now let's give some time for it to train, and that's why it takes lots of time to train, because it trains and samples on each and every algorithm with all the hyperparameter tuning and all. So that's why it takes time, and that's why we have taken only 20% of the data for training. For your use case, if you are running it in your local system, you can skip this part, and instead of sample train embeddings, you can directly input the train embeddings. I think we are done with the training in about 1 minute. Let's print the predictions. Now this is a fun part, guys. Ta-da! That's it. This is the model, that is SVC, support vector classifier, giving us the highest accuracy. And you can see here different metrics like accuracy, balanced accuracy, ROC AUC curve, that is receiver operator characteristics AUC curve, then area under the curve, F1 score, and so on. The best model that we have got is SVC, then NU SVC, Bernoulli NB, and so on. So you need not have to train each and every algorithm right from scratch. This lazy predict library does all the things for you. So that's it, guys. We have trained text classifier using this embeddings approach, and this you have done without fine-tuning any model. You have not fine-tuned the transformers model. You have just taken the embeddings part from the pre-trained model, that is all MPNet base V2 model, and only to create these embeddings GPU is required. But if you don't have any GPU at all, there are some open source APIs which give you functionality to create embeddings as well. So the entire thing or entire training you can do it from CPU. So hope you like this video. If you have any doubts or questions, you can ask in the comment section. I will make sure that all your doubts are solved. You can also connect with me on LinkedIn. Till that, take care and thank you, guys.